of the second algebra video, where we talk about solving equations with variables and fractions and integers. We're going to do something a little complicated, and it took me way too long to figure out an equation that I wanted, so I did not memorize it, but I'm going to read from my notes. Here's our equation. A times B plus B divided by D. And remember, I'm going to write D equals 2 up here. Okay, so we don't forget. Ha! All right, plus A over D. Oh, I'm totally going to run out of space. Okay, hold on. Okay. I'm going to try and write small. We'll see how that goes. Plus A over D, not B, divided by A over B equals B over D minus uh-oh, I can't reach. Oh my gosh, that's a B. That's a B right there. Okay. Oh, barely made it. Good times. Okay, so this is a pretty big equation, but it's okay. Well, for the first of all, we already know one of the variables. Cool. All right, so we got a little bit of information. Your urge, if you're new to algebra, might be to plug in that 2 for D. But wait, we're not going to do it just yet. And I'm blurry, so I'm going to tap on my face. Okay. Thank you for being patient with me in my less than professional video setup, by the way. I'm getting better, but we're getting there. But thank you for being patient. Anyway, okay, so your first reaction might be to say, hey, well, we know what D is, let's plug in D. But wait, hold on. For me personally, it can be hard to keep track of numbers because numbers get all smushy. And by smushy, I mean they can get messy. Smushy, messy-ish, yeah. So what I like to do, and this is probably product of me studying physics, because physicists really like to avoid numbers at all costs, till the very last step, and then you plug in your numbers. But I really like working with variables, because it is very clear to me what terms are what. So if this was an equation that represented a problem in the real world, each of these variables would have a different meaning. And so, you know, if we put in numbers from the get-go, we lose the meaning of those variables. So yeah, that's why it can help sometimes to wait until the end. Typically in algebra, you're not getting that advanced, but whatever. Okay, anyway, I'll stop rambling. Let's solve some more math. All right, so first things first, if you have a variable of the same type, you can combine it. So in this case, I have A times B plus B. B plus B, just like 1 plus 1, we're gonna get 2B. So anytime, that's kind of the first thing. Anytime you see a variable, you can think about it as having like an invisible 1 in front of it. Since multiplying something by 1 keeps that number the same, so 1 times A equals A, just like 1 times 3 equals 3. We want to be lazy, and so we can save ourselves some work by just remembering that there is always a 1 in front of each variable. So if you have 1B plus 1B, you have 2B. Ta-da! Pretty straightforward. Okay, so now this is a daunting fraction. It's a fraction over a fraction. Oh my gosh, how do we deal with that? Well, never fear. This is where one of those handy-dandy memorization tricks comes into play, and this is something that one of my favorite math teachers taught me, and it has stuck with me for my entire life, and I still find myself doing this, so I will pass it on to you. So, when you have a fraction of this type, you can write n d n. And the n means numerator, or top of the fraction, and d means denominator, or bottom of the fraction. And when you write it like this, it lets you rewrite this super messy, stacked vertical fraction into a more compact version that we can work with. So in this case, our two numerators are a, whoops, that's a terrible a times b, and our two denominators are, let me just double check, yes, that is a d times a. Yeah, okay. So, if you have a fraction like this that's like a over d over b, you can still do the same thing using the number 1 as a little bit of a trick. So if you have just a regular number, say you have like 2, you can rewrite this as 2 over 1. And that is equivalent. 2 equals 2 over 1. That's true. You can also write a equals a over 1. And so if you get something like this, you could write a over 1 and still do the n ddn trick. And so that's how you would extend that if you have like a regular number over a fraction or a fraction over a regular number. You just use this trick and then do n ddn. You do have to memorize the order n ddn, but once you have that in your head, it's not too bad. Okay, so now let's go on. B over d, can't simplify that anymore, so we'll leave it as is for now. And now we get to this ABC minus BC over C. Okay, so first of all, I have a minus sign out front, so I want to be very careful how I manipulate the inside. So I'm going to still put parentheses, and you'll notice that this ABC minus BC, all of these terms inside this fraction have a C in them. Haha! So what we can do is we can pull out that C and write it like AB minus B, all over C. And so what we did was we said, hey, I see that there's something in common with both of these terms. And so that's one of those fundamental properties in algebra. I want to say it's like the distributive property of multiplication or something like that. Google that and let me know if I was right, because I can never remember the terminology. But basically what it says is you can distribute and kind of take out in the same way. So if both of these terms have the same thing in them, you can pull that outside. Sometimes you'll find yourself going the other way. So you'll see a thing on the outside, whether it's a variable or a number, and you'll have to distribute it inside. And so in that case, it would come to both of these terms. But since we have a C on the bottom, our noggins are like, hey, let's get rid of as much stuff as we can. So I want to pull the C out so that I can go boom, cancel that. All right, now all of a sudden we have one less fraction. Heck yeah. Okay, so let's go back to here. So I'm going to rewrite this in a little bit more friendly way. 2AB over D plus AB over dA equals B over D minus, and here I'm going to distribute the minus sign. So we have minus AB minus minus. Oh, so this is where another new rule in algebra comes into play. 2 minuses equals a plus. That's one of those, wait, what? But if you think about it, it does actually kind of make sense. So if you subtract a negative, you get a positive. So 2 wrongs do make a right. No, just kidding. It doesn't extend it quite that well. But the same thing is true if you have 2 negatives multiplied together, you end up with a positive number. If only one of them is negative, then you do get a negative sign. And so oftentimes when I'm rushing in my algebra work, I will drop a minus sign, and it's often because of this. So when you're first getting started and you're practicing algebra, make sure you keep track of your minus signs. And always remember, a minus and a minus equal a positive. Okay, so now on this side of the equation, I notice that I have two different denominators. So we're going to use the same trick that we used in part 1 to combine these two fractions. And now I see that wait, did I do something wrong? Hold on. Is that supposed to be a C? Wait, 1 second. Nope, that's fine. Okay. Alright, I'll trespass Jen, and hopefully I made this make sense. Okay, anyway, so I have a D in one denominator and a dA in the other denominator. So what is different between these two? I'll give you a second to think. The A, exactly. Both of them have a D, so we don't need to worry about that. But one of the, this fraction over here, it has an A in the denominator. This one does not. And so that means that we have to multiply this fraction by A over A. Ta-da! And this one doesn't need to change at all, because once we have a dA in the denominator, we can go and combine the two. Cool. So now we have 2a times a, which is a squared, 2ab over d, dA, plus ab over dA equals b over d minus ab. Well, actually, so while we're at it, might as well combine these fractions too. Cool. So this has got a d in the denominator. D in the denominator. Look at that. And so I really like alliteration. Anyway, so if I multiply AB by D over D, then I get minus ABD over D plus times D over D plus BD over D. Okay, this is getting long. I'm gonna box this a little bit so we can keep track of that. And I'm gonna erase some of my upstairs work. Okay, so let's see. We got 2a squared, that's a terrible A, 2a squared b plus ab over dA equals b minus abd plus bd over d. All right, so first thing is that because we have a d in the denominator, haha, again, alliteration. It's almost like I did that on purpose. I actually did not do that part on purpose. So in this case, I can multiply both sides by d, because again, if you do that, you are actually keeping the equation the same. And again, the reason why is because if I were to move this over to the other side of the equation, I would divide by d, which would give me 1. Again, because d over d equals 1, just like 1 million, or I don't know, 102876 over 102876 equals 1, just as 10 to the 3012 over 10 to the 3012 equals 1. You get the point. If you divide something by itself, you get 1, because that thing only goes into itself one time. Pretty cool, right? Okay, so now we are going to get rid of these d's because we multiplied both sides by d. So now what we get is we get 2a squared b plus ab over a equals b minus a bd plus bd. Okay, let's see. And we are going to continue to simplify by multiplying both sides of the equation by a. Now we get 2a squared b. I guess I'll show you. 2a squared b plus ab equals ab minus a squared bd plus bd, whoops, plus, a bd. Okay. Oh, look at that. We have two terms that are the same on either side. So these will cancel because I would subtract them from both sides. Okay, so I'm just going to cancel those. 2a squared b equals, we're going to move this in front because I like having my positives. Although, well, okay, fine. We have a squared here, and typically convention says you should keep the squares out front. Basically, it's to keep track of exponents. And if you have higher number exponents, like a to the fourth, that would go in front. A squared negative a squared bd plus a b d. Okay, so now we find that we have an a in all of these terms. Cool, which means we can pull it out. 2ab equals negative, we'll pull the a out, we'll leave the negative inside, abd plus bd. And again, we can divide by a on both sides, or, well, on one side, so I'm going to divide that by a, and those cancel. And we go back to the top again, Where was the last one we had? It's that one. Okay. All right, almost done. And we get 2ab equals negative a b d plus abd plus bd. Okay. Look at that, we have a b in every term. We can do the same thing. Yeah. So we pull out a b. I'm gonna just go like that because we know what we're doing now. 2a equals negative ad plus d. Oh, that's interesting. Okay. So what I can do here, I really want to get the a by itself because we know what d is. And even if we didn't know what d is, if we are deciding that we're solving for a, we want to get all of the a's on one side of the equation so that we have our unknown on one side and our knowns on the other side. And that allows us to actually solve for the unknowns. Okay, so to do that, I'm going to have to pull out this d. So this side's going to stay the same. And I'm going to pull out a d and say negative a plus 1. Because if you pull a d out of d, what do you have left? You only have a 1, the one that was in front of this d. And since I like to write my negatives, I don't know, after, I'm going to rewrite this to say 1 minus a. Okay. And so now we can divide both sides by 1 minus a. Okay, so this has ended up a little bit more complicated than I wanted it to be. So at this point, I'm going to say F it, and we're going to plug in 2 for D. Okay, so we get, actually, I'm going to start from here. Let's see. Okay, so 2a equals, actually, let's start from here. Negative 2a plus 2. Okay, so if I were to move this over to this side of the equation, that means I would have to add. So to get rid of it on this side, you add 2a. that's really what algebra is about, is canceling terms on one side and making the equivalent statement on the other side. So if we get 2a plus 2a, that is 4a equals 2. Oh, I bet you can figure it out from here. Yeah. So in this case, a equals 2 over 4 equals 1 over 2. QED. Okay. That was a lot. Yeah, okay. I know. But here's the thing. We covered a lot of different fundamental algebra rules within that one equation. 2 expressions, 1 equation. The expression is just this, and the equation is made whole by the equal sign. The things in the equation are called terms. So like this is a term, this is a term, this is a term, etc. And honestly, we just covered like half of algebra. So I know that was a lot. I would encourage you to take the equation that we started with and try to get to this point on your own. And actually you should do that to double check my work, because I tend to rush algebra. It's one of those things like, yeah, whatever, I get the rules, I know how to do it, and then I'll drop a minus sign somewhere. So please do check my work. Let me know if I made any sort of mistakes along the way. And of course, if you have any questions about what we did, please leave that question in the comments. In the next episodes, we will be doing more of these types of solving systems of equations. I'll throw in more equations, more unknowns that won't necessarily all cancel nicely like this example did. Like the B's and the C's, we were like, well, I don't know what those are, but they canceled, so it's fine, whatever. And we will also be building up to quadratic equations, which are basically things with exponents in them. So trying to solve equations that don't simplify nicely. There are some tricks to that, and a lot of those types of things show up on the SAT. If you care about that, whatever, standardized testing, but yeah, it is pretty important to get into college or whatever. So yeah, and then if there are other algebra topics that you're super interested in, curious about, or struggling with, please let me know. I want to help you understand algebra better. This is a process that we're doing together. All right, I will leave it there for now. Thank you very much if you made it through both parts. I know this is long and a lot of math, so nice job. All right, thank you very much for watching, and we'll see you next time. Bye!